Hey guys, in this video we are going to solve literal equations. Literal equations are basically equations that have more than one variable. A lot of times in real life they're formulas for things. For example, the first equation that we're looking at is A equals BH, which is the formula for area of a rectangle, where B is the base and H is the height. So the thing is, with literal equations, you are going to be given an equation and also given directions for which variable you need to solve for. So in this case, we are asked to solve for B. Now, once we know this information, we solve these equations just like we would any other equation using inverse operations. So the first thing I'm going to do is locate the B in the equation. And I can see that in order to isolate it, I need to get rid of this H. So when I have two variables next to one another, I know that operation is really multiplication, and I undo multiplication with division. Okay? So if I want to get B by itself, that means I need to divide both sides by H. Okay, so my H cancels over there, so I'm going to be left with B equals. Now, the thing that's a little bit different with literal equations is we're not going to necessarily get a number here. A divided by H, we can't really do anything there because those are different variables. So I can leave my answer as B equals A divided by H. Okay, this next problem is very similar. Solve D equals RT for R. So this is the equation, distance equals rate times time. Okay, so again, if I want to get the R by itself, in order to isolate it, I need to get rid of the T. I know that RT is really multiplication, and I can undo that with division. So my answer would be R equals D over T. Let's look at another one. So here we're given the formula P equals 2L plus 2W, which is the formula for perimeter. Okay, we are being asked to solve for W. Okay, so this one's a little bit different because there's going to be more than one step. So just like I would with any other equation, I'm always looking to see if I'm adding or subtracting anything to the quantity that has the variable that I want to isolate. And I am. So I need to move this 2L. Okay, I can do that by subtracting because it's positive. Okay, so that would cancel. I'm going to bring down my 2W. And because these are not like terms, I'm just going to write this as P minus 2L. Okay, and then now I'm down to my last step. If I want to isolate W, this is really multiplication. I can undo that with division. Okay, and you may see answers written more than one way with literal equations. Okay, you may see your answer being left as P minus 2L divided by 2. You also may notice that if you split these up, you can simplify a part of this. So I think the best way to write this is P over 2 minus, I can kind of do my work off to the side, 2L divided by 2, my 2's would cancel. So it's really P over 2 minus L. I think that's the best answer. But if it were a multiple choice test, for instance, you may see that first one. Okay, let's look at this equation. Q equals C plus D over 2. And we are asked to solve for D. So D is in the numerator, okay? And we want to keep in mind, it's kind of like we have invisible parentheses around the quantity in the numerator, which means that I'm not going to deal with anything up here until I get rid of my denominator, this divided by 2. So I undo division with multiplication. My 2's are going to cancel. 2 times Q is 2Q And now I have C plus D. So for our last step when solving for D is to isolate D by getting rid of the C. And I do that with subtraction. So 2Q minus C is equal to D. Okay, we'll do one more. So we are given V equals 3K over T and asked to solve for T. So in this case, T is in the denominator. Well, when I see something that's just in the denominator, this is really the same thing as like 3K times 1 over T. And I always want to solve for a variable that's in the numerator, like T over 1. So I need to get rid of this T down here. So I do that by multiplying both sides by T. That's going to get that T out of the denominator. Okay. And now I have VT equals 3K. Okay, and again, I'm trying to get T by itself. So now I can undo this multiplication with division. So T is equal to 3K divided by V.